Perfect. Yes, thank you very much for the introduction. And I'm going to say something about CCS in the Netherlands, what's happening. And I would like to conclude with some remarks on, actually some notes on what we should consider also in terms of the data, that is the data management. Let's see. There's the title. I would like to start with a brief kind of bird's eye view of how what's happening in the subsurface in the Netherlands. Let's say kind of activities that we're undertaking. Nationally, let's say gas and oil are very much in decline. Currently, we see rapid decline of production of gas. So that is going progressively in the stage of decommissioning. If you look at more at the activities that are still very much ongoing, salt production is business as usual, underground gas storage as well. And if you look at the left-hand side of the graph, we see that new technologies are emerging. CCS is more in the startup phase, let's say, getting towards a point where we get, let's say, a point where we can scale up. But we still need to start with first injection projects. If you look at hydrogen, that is very novel technology, but also there we have already applications for storage in salt caverns. And geothermal is ramping up, but it needs to accelerate. You see also coal mining, by the way, that's not something we do anymore, already a long time. But we see currently all the effects in the region of the southern part of the Netherlands, and there's a lot of activity and policy attention for mitigating these kind of risks and effects. I also wanted to show here there are very important connections for the Netherlands. So although we have declining gas production in the Netherlands, these gas fields are going to be used for other uses, CCS in particular, but also hydrogen storage is being considered, and of course salt mining is currently being directed to mine the salt in such a way that we get useful caverns for storage. So that is important part. And UGS, you see a question mark, how long will we still have UGS in the Netherlands and still demand for UGS, underground gas storage? And that means what is the, if we decommission these kind of sites, that can lead to production of the cushion gas that is still in these sites. So that's the arrow there. A picture briefly showing the situation for gas production in the Netherlands. You can see that the Groningen gas field, blue part here, the production on the upper left side, has ceased because of societal issues and especially the seismicity and the damage to buildings in the area of Groningen. Groningen is being closed off entirely, the wells are being cemented, the infrastructure is being removed, and the field is left with some 500 billion cubic meters of gas inside. So just consider what that is. You see the picture of the licenses of natural gas and oil production. So the yellow parts are production, orange is exploration, and you see the image of 2020. And then there's also the image which I just got from our internet yesterday, and you see that it's really becoming a kind of Emmentaler cheese image. A lot of holes in the licenses. So yeah, we see gradually industry moving interest to other areas and many licenses being relinquished. Of course, on the lower left side, you can see that while gas production drops for the Netherlands, we were an exporter until 2017, and now we are very much import dependent. So, sketching the big picture. So while gas production is declining, we see a lot of development in CCS. Two important projects, Portals and Aramis, are, let's say, moving towards a stage of operation. Especially Portals is going to move in this area very soon. So Portals being the first one, and Aramis is a trunk line project which is going to connect gas fields in the K and L blocks much further north. And there are several storage projects projects already preparing to be connected to the RMS project. So there's a emerging picture for CCS in the Netherlands. Many projects and players are currently taking steps there. And if we make a, let's say, an overview of what could be considered as a in the coming 5 years, let's say, as what kind of storage injection capacities we could realize, this will be more or less ballparking in the range of the obligation. So I took the image from the presentation yesterday from Watch, the Watch EU Article 23 presentation yesterday. So this was, I think nicely covers it. If you look at storage licenses, you can see that quite a few licenses are in gas fields. You see the dark purple parts in the southern parts of the Netherlands. That's the Porters project, and you see some spread out fields in the L and K blocks where licenses are either applied for currently in the application stage or also granted already. The K14 FAA field in K block, the dark purple, has been recently granted. You can also see exploration licenses, larger areas where currently exploration also partly in aquifers is taking place. It's the same picture, but now I've also included the gas fields that are in the North Sea. I try to visualize, let's say, how the license picture has evolved over the past years. I think in 2008, starting with Barendrecht, and that license was not granted finally because also of public objection. Barendrecht was a storage site under the city of Rotterdam and Pijnacker, so that was in a densely habited area. Later on you see that licenses are gone, the CCS moved offshore. This is also the policy. Only storage offshore is allowed in the Netherlands. And you can see various steps, I think, nice to mention. And in 2020, halfway 2020, the subsidy scheme was introduced also for CCS projects, so closing the gap between the ETS price and the project cost, so that companies can apply for the subsidy scheme. This subsidy scheme is currently being upgraded also to include storage sites that are not in the Netherlands. So as long as the CO2 is captured in the Netherlands, it can be stored in other countries, and that is applicable also for the subsidy scheme. And you can see a rapid rise in the number of licenses. What we see in the license development is, let's say the handling of licenses, that's a lengthy process. It's quite a novel thing. It's complex because you have the storage license, but also the storage plan that is included. So it's a complex process. It goes back and forth with the operators to get more information. So the advisors and the ministry constantly asking new questions, and then it comes back and we have to reevaluate. So it's currently still lengthy processes that are, let's say, subject to possible more efficiency. But anyways, the picture evolves here quite rapidly. Okay, we have, let's say, these licenses that are there, but we also do some portfolio analysis, and recently we have also published a report on the potential for CO2 storage in gas fields. So you can see the QR code and the link there. What we have done is really looking at, first of all, at the theoretical, and I know we had a discussion yesterday about theoretical and capacity, etc. So I don't want to stir up that discussion too much here, but for the theoretical part, we define this really as how much gas has been taken out of the gas field, and and then you can, with a conversion factor, just calculate how much CO2 would that mean. Then you get to a effective capacity that takes some technical reductions, and then the practical capacity takes further regulatory and economical reductions, so you get a kind of technical capacity that you could fill, but with all kinds of assumptions, of course. But you can see that finally, if you take all the, let's say, small and large fields together, we are in the range of 1,700 megatons offshore in gas fields. If you only take the large fields above 10 megaton capacity in the Rood-Liegend and Trias only, it's slightly above, let's say, around 1,200 megatons. If you take these figures, you can make a kind of a, let's say, indicative profile how these capacities will come available over time. So the green curve here is more or less the low case. It only considers currently producing fields that will be decommissioned, and then these will come online in, let's say, be available for storage. So that's one assumption. And the high case assumption here considers that all existing fields that are already abandoned and closed are also coming online after 2028. So that's not a realistic case, of course, but it's just to see where we could find bottlenecks in bottlenecks in development of future capacities for CO2 storage. And looking at that, I just made a picture here from an assessment in the Netherlands. We do this kind of integrated energy system analysis. So we look at scenarios, what kind of choices could we consider for the future energy system. So whether you go very much focused on renewables, or are you going to remain importing gas or doing CCS with for example, biomass, etc. You get very different scenarios on how the demand for CO2 will emerge over time to remain to our target for net zero in 2050. And you can see that that some of the lines are, let's say, within the low case, but also many, especially the yellow and the red case, will extend above the low case scenario. So it's good to investigate what kind of how can we establish enough capacity. So we look only at gas fields here, but we also look at the role of aquifers in the Netherlands, aquifer storage. There can be several benefits. First of all, I didn't say here with the practical capacity, but it doesn't include let's say the limitations you have in spatial planning offshore, and it's very busy. So if you take those kind of limitations spatially, then you see that that a lot of capacity is not available possibly. Aquifers could be a solution for this, and also for the long term, if we are importing a lot of CO2 and we are going to inject then at some point, 2050, 2060, we will absolutely depend on aquifer storage on top of the gas fields. So there's quite some benefits. So we have to investigate it right now because of the long lead times getting to aquifer storage in time. So we do these kind of studies together with our partners. And see, what I would like to say, what is important here is also data. I think data, there's a few things that we need to consider for data very much, in time. First of all, safeguarding data from the industry. Now, we see a decline of gas in the Netherlands, so the industry is moving their interest and focus to other areas. Licenses are being relinquished. So the question is, what happens with all the data that the industry has? Because that is critical data, not only for CCS, it's also critical for geothermal, for other uses, for hydrogen storage, etc. So for the energy transition, we need to have optimal data. As TNO, as the Netherlands, we have a very open and transparent data, let's say, regulation. Still, considering that, we can consider that we have only a very small part of what the industry has. And consider this, billions have been spent on getting this data developed over many, many years by the industry. It takes, let's say, millions to safeguard that data. So there's a huge price difference, and I think we have a responsibility to make sure that this data is not going to be lost, including also the experience that this industry has. And I think the benefit from having this kind of data, we can do that together with the industry, joint industry projects, making dedicated products for storage, but also making sure with proper data that we can do better spatial planning. Because without proper data, you will select the wrong fields, possibly you make not the right choices in where you want to plan your storage in the future. Managing and leveraging monitoring data. So CCS is going to come with a lot of monitoring. So there will be enormous monitoring streams, whether it be 4D seismic or 20 years monitoring after post-closure. So we need to make sure that our systems are ready to take up that monitoring data, that we are able to valorize that data in research, and make sure that we get the best out of it to make proper decisions also in the future. So monitoring, I think our systems need to really be ready for that, and that's still a lot of work. And the last point that I want to make, and that's also the final for this slide, AI is going to be a disruptive development, I think. We are very much used to traditional mapping, traditional data management systems. That's going to change very rapidly, and it's already changing. So getting access to the data, making sure AI technologies are making proper use of data, that the data is available for those kinds of studies, then we can get a lot of let's say, good developments out of that, and I think this will also stimulate and accelerate technologies like geothermal and CCS. We have to do this in time. It's already happening. It's upon us. So we cannot wait another 10 years or 5 years. We have to act right now to make the benefits of these points. And with that, I would like to thank you for your attention.